subtitles made by and crafted with care. Dimatorzok. Well, as before, my name is Yuri and today we are discussing quantum superposition. We are trying to explain it and find some keys to understanding it. In classical mechanics, superposition is quite simple, quite linear, and it's fairly easy to analyze. Let's imagine a simple example. You throw stones into the water. If we are approaching the river, let's consider examples that can be seen right now. Oh no, not seen. The ice is still there. But nevertheless, imagine you are throwing stones into the water. You throw 2 stones simultaneously. These stones obviously start to provoke the appearance of mechanical waves. The water, as a mechanical medium, begins to oscillate. Oscillations are formed in it. And if these oscillations meet each other, what happens? The addition of these oscillations occurs. We won't delve into special details here, because there's a lot of interesting things to discuss. 2 mechanical waves, which propagate in some medium, will overlap with each other in one way or another, and in practice, we will observe the result of their interaction. This is the general rule for all such cases. And, according to the general rule, if we look at the point where these 2 waves meet, where they intersect with each other, what will be observed at this point? Correct. Superposition. By and large, mechanical superposition is a phenomenon related to the fact that 2 objects, 2 waves in this case. It is better, of course, to apply this to, let's say, a general understanding of the problem, not just to waves. And 2 such waves met, interacted purely mechanically, and formed a cumulative result. So what happens in the quantum world, and is such an understanding of superposition appropriate for us? Well, you probably already guessed that it is not appropriate. In order to somehow understand what quantum superposition is, let's also give a simple example. Now let's just go down and provide a simple example. And look, even here the forest ran through. Imagine that you are tossing a coin into the air. You have several stable positions. The coin can land heads up, it can land tails up, that's obvious. But the coin is also in the air for some time. During the time the coin is spinning in the air, it has some indeterminate state. And indeed, think about it. What state will the coin be in while it is spinning? Just like that, in flight, how can one describe, from the perspective of classical physics, the state in which it will be? Well, probably something like probability logic would be suitable here. Although, it would be quite strange, since probability reveals itself at the moment the coin falls. In fact, in the air, the coin will be in a state where it is both heads and tails at the same time. Okay. Do you recognize some parallels? Yes, this is exactly what we hear about quantum superposition. In fact, as long as the coin is in the air and spinning, it is in all states at once, simultaneously, or at the same time, and describing it somehow will be extremely difficult. And probably more than half of those who constantly mention Schrödinger's cat in conversations, in dialogues, and so on, do not understand the true essence of this example. And so, as you remember, Schrödinger said that you can take a cat, place it in a closed box, and in this closed box place a certain capsule with a poisonous substance and open the capsule as the particle decays. At the same time, take a particle that essentially has a 50-50 decay probability. That is, there is a 50% chance the capsule will open and release the poison, and a 50% chance the capsule will not open. And what can we then say about the state of the cat? Well, the cat is of course both alive and dead at the same time. And this is inevitable because we do not know the state of the capsule. And it's 50-50? We can only find out the state at the moment when we actually open the box with the cat. And this example has become, let's say, an illustration that such concepts are not very suitable for the macroscopic world. Indeed, what is a cat that is both alive and dead at the same time? Logic tries to immediately say that the cat is either alive or dead right now, but it cannot be in 2 states simultaneously. However, quantum physics suggests exactly that. And this strange state, which was related to quantum particles, began to be described by the so-called wave function. This is another cornerstone that serves as the foundation for all of quantum physics. This wave function, or state function, described a particle and implied that the particle simultaneously has all its possible states. What are all possible states? This is, for example, all possible spin values at once. And a specific value appears only at the moment when the observer effect comes into play. If we exaggerate all this, it turns out that the quantum wave function describes the state of a particle and assigns it immediately all possible properties. And the effect of interaction with the observer allows in this quantum world to single out a specific value and convey it to our macro world. This is all a bit abstract, but I think such a simplification is quite acceptable. I think I won't be heavily criticized for it. One way or another, this is the state we are initially talking about. The state when it seems like a coin is suspended in the air in all possible states at once. This is quantum superposition. And essentially, quantum superposition is all the possible states of a particle that can exist at that moment for that particle. Any quantum particle, any quantum object simultaneously exists in all possible states at that moment, but they have different probabilities. And this difference in probability allows for the selection of a specific state that is most suitable for a particular case. I want to note that probably, at present, no scientist can thoroughly explain to you why this happens and how it is possible. At some point it just happened that the quantum world lives separately. The quantum world has its own patterns and its own working principles. And this needs to be understood very clearly and well. In our case, quantum superposition is an example of this, let's say, indeterminate complex state, which is different from what we are used to seeing. Quantum superposition is a mathematical state, but here an interesting question arises. Can the terminology of mathematics be used primitively in physics? This is a big complex topic for understanding and realization. And I'm afraid we don't have the right answers yet. In principle, all modern physics, all particle physics, and especially quantum physics is built precisely on the understanding that mathematics is what primarily works for us. We always want to present this or that quantum phenomenon to our macroscopic view, our classical approach. But doing this is very difficult. Finding any analogies is practically impossible. And any example we provide to describe quantum superposition will, for the most part, be incorrect. Interestingly, this phenomenon is best understood, in fact, by mathematicians, but I hope it has become clear to you what quantum superposition is, how it works, and how it manifests itself. Now you know that quantum superposition implies all possibilities at once, whereas ordinary superposition or a regular state implies only one, a specific option. Quantum physics is the complete absence of specificity at the moment of the system's existence. As for how all this is dispersed, so to speak, in the universe, how it exists in space, and how it formulates and forms itself in reality, it's probably very difficult to say. And I think we will dedicate more than one video to this topic. Attempts to understand this state. Imagine the state of superposition. How can you even visualize it? Well, of course, mathematically it's clear that it's like a spinning coin. But what happens somewhere out there, right at that level where all this, forgive the tautology, happens? What is a particle that has all states at once?